Today we're going to talk about identifying linear functions. So we're going to get into our unit about graphing in the next couple of days, but today we're going to decide if something is even considered linear. So let's look at it visually first. If I'm looking at these two graphs, if I'm trying to decide if something is linear, well, let's go to the definition of linear. Linear, it has the word line in it. It has to be a constant rate of change. So it cannot, there can be no bends or turns or random curves. So as I look at these two examples, my obvious linear graph is B because it is a completely straight line with no bends or curves. That makes A non-linear because I've got this is going down and then all of a sudden it's going up. Okay, that cannot be happening in order to be linear. It has to have constant. So constantly increasing or constantly decreasing. So take a second when you get to this next screen, pause and decide if these are linear or nonlinear. All right, I'm gonna mark the ones that are obviously linear. So I've got my two lines. So these two are linear. Now as I'm looking at the remaining graphs, I can see that this second graph goes up and then goes down and then goes up again. So that is not constant or straight. So this would be nonlinear. Now the last one on here always trips people up because they say it's straight. There's two straight lines on here. It must be linear. Remember, there cannot be any turns or curves at all. It has to be constantly increasing or constantly decreasing. And this graph is decreasing and then increasing. So non-linear. Now let's look at them from tables to see if they're linear or nonlinear. In order to be linear, and I do want you to write this down, if in order to be linear, it needs to have a constant rate of change. Now that's another name for slope, which is the change in, and the little triangle means change in y divided by the change in x. And we're going to get more into slope later, but the main thing I want you to focus on is it needs to be a constant change. The pattern needs to remain the same. So as I'm looking at these two examples, example A, as the x value goes up by 3, the y value is decreasing by 6. Now, if this is a constant rate of change, okay, this pattern is going to remain the same. So as I increase by 3, it decreases by 6. As it increases by 3, it decreases by 6. So I would consider this linear. Now, what would I consider nonlinear? As this increases by 2, this increases by 7. Well, so far, okay. As this increases by 2, so pattern same so far, but this increases by 11. This right here is not constant. Okay, these are constant, but the y's aren't not constant, so this makes this non-linear. I don't even need to finish this table. I automatically know. Now, one thing I want you to be aware of, or something that might trick you into thinking something may be nonlinear, let's go back and look at table 1. If I included one more value and it was 13, 16, and I were to map its change, plus 1 minus 2. I know there's many of a people that might say, hey, that's nonlinear because the pattern changed. Instead of adding 3, I added 1. And instead of minusing 6, I minus 2. Well, think about it for just a second. The x value, it changed how much it increased, and the y value changed how much it decreased. Is that change could it still be considered the same? So remember, slope is the change in y. So it normally decreased by 6 for the change in y, and it normally increased by 3 for the change in x. If I write down this new pattern, it decreased by 2 and it increased by 1. Are those fractions equal? Are they equivalent? Well, 6 over 3 is negative 2, and negative 2 over 1 is negative 2. So this still would be a linear function. Even though the pattern looks like it changes a little bit, it stays the same. It just simplified its pattern. One other way you need to be able to tell if something is linear or nonlinear is from a set of points. So for example, if I had 1, 1, 2, 5, 3, 9, 4, 13. Okay. Now it's not written as a table, but you can if you'd like to. X, Y, remember this is the X and this is the Y. Or you can just say, hey, X is increasing by 1, Y is increasing by 4. Does that rate stay the same? X increases by 1, Y increases by 4. And as I look at the rest of my points, they all stay the same. So this would also be considered linear. Take a second, pause, and decide if these are linear or nonlinear. All right, this example is linear. All of these values increase by 3, and all of these values increase by 2. Okay, no matter between which two values I go. On the second example, all of these values increase by 1, but all the values on the y, they aren't the same. This is minusing 6, this is minusing 4, this is minusing 2, then it stays the same. Okay, so this is nonlinear. And this last one is linear. It increases by 1, and this also increases by 1.5. Now, last way to tell if something is linear or not is from an equation. Now, please write these down so that you can refer to them later. The first point right here is telling you what it must be like. So an equation, in order to be linear, has to be able to be written as y equals mx plus b. Now, each of these below fits that format. This one directly below it is the most obvious. Y equals 1/2 x minus 7. Fits that form. As I go to look at my other examples, you may say, that's not y equals mx plus b, but here's why. Okay, notice that I could get y by itself and solve it by minusing 2x and dividing by 3, and I would divide both of these by 3, and I could convert that into y equals mx plus b. Same with this first one. I could distribute and add 4 over here and simplify, and it would be y equals mx plus b. So, how do I know that something is obviously not linear? There's a few ways, and they are these. So, I would write these down. If something is nonlinear, it may have exponents on the variable, or the variable might be the exponent. For example, x cubed, variable has an exponent. Y squared, variable has an exponent. Or it might say y equals 3 to the x power. My variable is in the exponent. Next thing that it cannot be, my variable cannot be in the denominator of the fraction. So x is in the denominator here, and y is in the denominator here. On example number 4, the next thing, y cannot and x cannot be multiplied together. If they are being multiplied together, they are automatically not linear. If I solved for y, I would end up with y equals 5 divided by x, which is x in the denominator. The last thing that cannot happen is you cannot have a radical surrounding your variable. If you do, it's automatically nonlinear. So let's look at just a couple of examples to make sure we can tell the difference. 5, 6, and 7. Number 5 is obviously linear. There's no variables. There's no exponents. There's no square roots. There's no fractions. It fits in the y equals mx plus b format. 6 is a little less obvious. There is a fraction, but is there a variable in the bottom of that fraction? If the answer is no, and there's no exponents or anything like that, then I'm going to automatically go for linear. Now, the reason why it's linear is because it can be written 3 over 5x. I can pull my fraction in front of my variable. Last one, variable has an exponent, automatically non-linear. Take a second, pause, and decide if these are linear or non-linear. All right, I'm going to separate these out so we can see them all. I like to automatically go to find the ones that are nonlinear. So I know this is nonlinear because it has a square root around the x. I know this is nonlinear because the x is in the exponent. I know this is nonlinear because x is in the denominator. And I know that this is nonlinear because there's a variable with an exponent. So each of those 4 examples are nonlinear. Now let's look at the remaining 2. If I distribute the 6 into both of those terms, equals y equals 6x minus 6, that's the y equals mx plus b form. So this is linear. And this last one, there's nothing telling me that it isn't. And if you're not quite sure, remember I have y equals no x's, 0x plus 3.8. So it does still fit into that form, and it is still linear. All right, if you have any questions, please reach out to your teacher and make sure you look for your assignment on Canvas.